In this video, I'm going to talk about hybridization. So hybridization is the combining of atomic orbitals to form hybrid orbitals. So that's the combining of atomic orbitals to form hybrid orbitals. So an hybrid is what you get after a combination of two different things. Okay. Now we have got different types of hybridization depending with what is reacting. So in this video, we're going to talk about three of them: sp3, sp2, and sp hybridization. So let's start with the sp3 hybridization. So in the sp3 hybridization, you have got one s orbital combining with the 3p atomic orbitals to form one sp3 hybrid orbital. So what you have is s plus p plus p plus p, and that is what is giving us sp3 hybrid orbital. So this orbital is one which has come from a combination of 4 atomic orbitals. This hybrid orbital is only one. Alright, so this kind of hybridization is very important when it comes to compounds like methane. So you have got carbon. Okay, so we have got carbon. Now if we draw, we know that carbon has got only 4 electrons in the outermost shell. So therefore the electron configuration is 1s2, 2s2. So this carbon which we have, let me just recheck that. Okay, carbon, we are not talking about only the outermost shell, we are talking about the atomic number to write the electron configuration. So it has got 6 as the atomic number. So the electron configuration is 1s2, 2s2, and then 2p2. So that gives us 6. Alright. So now this is going to be like this. We have got the 1s there, and then the 2s there. Again we have got the 2p. So what happens is, if this carbon wants to react with 4 hydrogens, this s orbital, remember it is the valence shells which take part in a chemical reaction. So the 2s and the 2p orbital, those are valence orbitals. Okay, let's just clarify more so that we get to understand better. So you have got the 1s orbital, we have got the 2s orbital, and then we have got the 2p. Now the 2p orbital has got 3 sub-orbitals like that. So when this is carbon, when carbon wants to react with 4 hydrogens, it means it needs to have 4 orbitals where each hydrogen is going to come and share its electron with. So what happens is, these two, which are the orbitals in the outermost shell, are going to hybridize. They are going to come together to form an hybrid orbital, where they are going to be 4, where one will be the s, which is this one, and then the rest will be these p's we can see, the 3 p's. Okay, so this is a p, this is a p, this is a p. This is what we call the sp3 hybrid. So therefore, and then this will still remain the 1s. So when carbon undergoes hybridization, these are the orbitals which are present. Okay, we have got the 1s and then the sp3 orbital like that. Now again, one thing that maybe we need to know is, the hybrid orbital is between the two orbitals which have come together. It is between the 2s and then the 2p. Now it is closer to the 2p than to the 2s. Why? Because it is 3 2p's which have come together about 75% with only one s which is just making 25% to form now, if you put them together, 100%. So it is these orbitals now which are going to react each with an hydrogen. Okay. So if we can write the electron configuration, this is 1s, that is sp3. Carbon has got only 6 electrons, so that is 1, 2, 3, 4, 5, 6. So when it undergoes hybridization, we have 1, 2, 3, 4, 5, 6. But it is reacting with 4 hydrogens. These hydrogens are also bringing their each bringing an electron. 1, 2, 3, 4. Hence now the orbitals are completely filled up. So that is why hybridization is very important for a reaction to be able to occur. So when we are talking about hybridization, of course we know if we are talking about the s orbital, the s orbital is simply like an oval. Now for the p, it has got 3 suborbitals. We've got the px, which is along the x-axis. We have got the py, which is along the y-axis. And then we have got the pz, which is along the z-axis. So these are the 3 suborbitals which we have. So when a compound undergoes sp3 hybridization, just to again put what we saw, it undergoes sp3 hybridization. This is the 1s, we have got the 2s and then 2p. So these are coming together to form 4 like that, which is the sp3. So what is coming together is we have got the 2pz coming together with the 2py, again together with the 2px. So this is now going to form one orbital. Okay. And then remember it also came together with an s, a 2s. So these are forming now one orbital, which is going to look like. So where we've got.
And this some exercise.
Okay. So this is now, this only one of this is sp3. Even this one is sp3. Even that one is the sp3. Even this one is the sp3. So this is now the sp3 hybridization. So we are forming 4 sp3 hybrid orbitals. So if this reacts now with our carbon, so I mean with our hydrogen, so what we are having is we have that. So each hydrogen is going to come and attach there. Now each hydrogen is coming with only 1 electron. So it came with its electron. Even there it is going to come with another electron. Let me just make this one much clearer. So we have
What name is this?
okay, where each of those are sp3. So it's going to react with
Huh?
like that.
Because I'm at she's also in 24. Group, this is group what?
So each of these is an hydrogen which has come.
This one.
Okay, each of them is an hydrogen. Now remember carbon, we said it has got the electronic configuration of 1s2, 2s2 and then 2p4. So I mean 2p2.
This game.
So it means these two which have come together, they've brought in their 4 electrons.
Oh,
So
yeah.
those 4 electrons which have come, which we can see there, are going to be in here, like that. Now each hydrogen is bringing its own electron. So those are the electrons which will be brought by each hydrogen. And so we can see now the reaction in CH4. And hence, hybrid orbitals, this is an sp3 orbital, making a reaction with the s orbital from hydrogen, because hydrogen has got only one s. Okay, same with this one, which is sp3, and the rest just like that. So that is sp3 hybridization. The other type of hybridization is the sp2 hybridization. Now for here, only one s come together with p, with 2p orbitals to form sp2. Let's talk at the same time about carbon, which has 1s, 2s, and then 2p, like that. Now only 2 of these are coming, so we are just getting 2, and then with 1 here. So what we are going to have in the hybrid, the 1s is there. So the one which will be formed will be between these two, so it will be somewhere here. So these will only be free, where this is sp2, this is also sp2, this is also sp2, like that. So instead of writing them alone like that, we are going to just put sp2 here. But 1 had remained here, so we have remained with 1 2p orbital, like that. So that is the hybridization that occurs. So remember, 1p has remained, but here we have got, this is sp3, like that. So what is happening is we have got a 2s coming together with okay, so it is coming together with the p's. Now remember, 1p had remained there, so 1p is remaining unhybridized. So we don't know which p is going to come. So we have the 2p. Let's say this is 2p y, and then let me put 2p z. Okay, the other one is not going to undergo hybridization. Another one is not going to undergo any hybridization, so it is just going to remain like that. So what we are going to form, remember, we have got one which is the 2p, oh, this is x, so the 2pz. So this one hasn't undergone hybridization. So what we are going to form is, we only have one orbital which will be one like that, another one like that, another one like that. So each of these which you formed, so each of these is sp2, because we've combined only one s and 2 p's. But this one, remember, it has remained. So this one which has remained will simply stay just like that. There, I've put it in red. It hasn't hybridized. So now we can see a reaction such as in a compound C2H4. So this compound is like this. So if we consider this carbon, it has reacted to 3 things. We have got an hydrogen on top, a carbon this side, and an hydrogen this side. So this carbon has reacted with 3 things. So it undergoes sp3 hybridization, where we've got 1 orbital for the s and then 2 for the p. Okay? And which of each of them is going to react with the hydrogen, and then another hydrogen, and also a carbon on the other side. So what we are going to have is this orbital is going to come to react now with the others. Okay, so this one, remember this is carbon. Now we are talking about ethene, C2H4. So one carbon, we know the hybridization. We know that it formed like this. This is one carbon. And then another, and it had also the orbital which was not hybridized. So that is a orbital that hasn't gone under hybridization. And then this is the first carbon. The second carbon will also be like that, having these orbitals. But we are also going to have another orbital which didn't undergo hybridization. So I've put it in red. So this is the p orbital, which we can also see down here, because a p orbital goes like that. Okay, and then this is the sp3. This is also sp3. This is also sp3. Same with this one here, it is sp3. This one also is sp3. This one also is sp3. But this one is simply a p orbital. It hasn't undergone any hybridization. So what is going to happen is those sp3s are going to react now. Remember, we have got 4. Okay, we have got 4 hydrogens. So those 4 hydrogens, one is going to come here, another one is going to come there, another one is going to come here, and then another one is going to come there. So an hydrogen is bringing an electron with it, which is going to come in those orbitals. And remember, the carbon already has electrons also in there, like that. Now carbon had 4 electrons, just as we saw in the previous one. Okay, 4 electrons in the outermost shell. But this carbon, we've seen it has only contributed 1 electron here and 1 electron here. So we have got electrons which have remained. Okay, and then it has also contributed another electron here. Same, this other carbon which is here has also contributed another electron. So this one has contributed 3 electrons, 1 electron has remained. So that electron which has remained will be in the p orbital. Even this one which has remained is going to be in the p orbital. So this will be the hybrid, the reaction that is going to happen. Now these p orbitals which have not reacted can also overlap. They can also overlap. That overlapping is what forms a double bond. So hence we have got this structure like that. So the results of a double bond is due to the overlapping of the p orbital, which was not hybridized. So that is what happens in sp2 hybridization. Okay, so that which we can see, maybe let me just go a little bit behind, we see what. So this one which results because of overlap is referred to as a pi bond. Now this bond which is formed here, or just any other bond which is formed without the overlap, is called a sigma bond. We'll talk about that more. Let's talk about sp hybridization. Now talking about sp hybridization, let's use the same carbon. We've got 1s, we have got 2s, then we have got 2p. Now here only 1s and 1p is going to come together to form our compound, and hence we call it only the sp hybridization. Now how does it really happen in this case? Okay, so the happening is we are just having this one coming, and then this one also, one of them coming. So the result will be, we are going to have two sp hybrid orbitals, and then remember two have remained there. So the two which have remained are there, the 2p. And then you've got the 1s which is down there. So this is how it's going to happen. So what we have is now, let's show it in the same diagram. And a 2s is coming together with, let's say this is 2py, and then 2pz, and then 2px. But only only one of these is going to come together with the s. The other two are going to remain. Okay. So the orbital that we are going to form then will look something. Okay. So it will be something like this. So this is an sp hybrid orbital. This is also an sp hybrid orbital. But remember, we've remained with this one and this one. So the other ones we have remained with 1p, like that, and then we've remained with another p, like that. So this is a p, this is also a p. So this will be the hybrid orbital which is going to result. Now it is this one which is going to undergo a chemical reaction to form whatsoever compound that we want to form. Okay. Now take for example, what compound can we use in this case? We can use C2H2. Let's see how the reaction occurs. Now C2H2, this compound is like this. We have one hydrogen there and then one hydrogen here. So because this carbon is only reacted to two things, one thing this side, one thing that side, that's why it undergoes only sp. Okay, because it has no many things to react with it. Okay, so now let's look at that one. How is the reaction going to occur? So what is going to happen is, we have got sp hybridization. We are talking about C2H2 like that. Okay, so in this compound what is going to occur is, we have got only only two hybrid orbitals. So let me first show those which are not forming which are not undergoing hybridization, like that. And then we have got another one. So the one which has undergone hybridization, I'll show it in white. Okay, like this. And then, so this is the sp, this is also the sp, and then these others, this is the p, and then this is the p. Okay, like that. So this sp is going to come together with one carbon. Remember, it is like this. It's going to come together with one carbon. So this one is going to come together with a carbon. So this is also the sp from now another carbon. So this is the sp also from another carbon. Let me use the same color for the ones which have undergone hybridization, so that they don't confuse us. Okay. Again, we have got those which haven't undergone hybridization. We have got the p, and also the S. I mean the another P, not S, another P. So this is sp. Now to this one, this sp, that is where hydrogen is going to attach. So an hydrogen is going to come and attach here, and then also to this one, which is this side, and hydrogen is going to come and attach. Now what is going to happen is these p's which have remained, we've got a p, and then you've got another p. This is another p, like that. So these can overlap. Okay, so these which have remained are able to overlap like that. And then even this one also, which is not in green. So the other p's, remember the p's, which ones are vice? Okay, the greens are the p's and the yellow ones are the p's. Okay, like that. Let me make it much clearer. Okay, so what we have is this is a p, this is also a p, and then the one in green is also a p. So what I'm saying is these in yellow can overlap, and those in green can also overlap. Because of such overlapping, a triple bond is going to be formed. So this is the bond which results because of the overlapping, that triple bond. Okay, and that is why sp hybridization, you are going to even find a triple bond such as in this compound. So that was about hybridization. So another thing maybe we need to understand is when we are talking about hybridization, whenever we see a double bond, a single bond, what does it mean? So a single bond always has one sigma bond. If we see a double bond has got one sigma bond and also one pi bond. If we see a triple bond, this one has got one sigma bond and also two pi bonds. As we saw, there were two overlaps between the two orbitals. So two pi bonds and also a sigma bond where there is no overlapping. Okay, so this is the thing when you're talking about bonds. So a pi bond only starts from a double bond, a triple bond. So we can have a compound such as so I want to determine how many sigma bonds are in this compound and how many pi bonds are in this compound. Okay, so let's first count the sigma bonds. So we need to know that in each single bond and double bond there is only one sigma bond. Let me use another instead of just writing it like that. Let me put a bond like this. Okay, so it means on this one I need to remove this, and then this one is like that. Okay, so let's count how many sigma bonds are in this compound. So here there's one sigma bond, two sigma bonds, three sigma bonds, 4, 5, 6, 7, 8, 9 there, 10 there, 11, 12, 13. So we have got 13 sigma bonds. What of the pi bonds? How many pi bonds do we have? So 13 sigma bonds. Now pi bonds here, you just go to the double bond. A double bond has got one pi bond, one, and then a triple bond has got 2 pi bonds. So 1 plus 2, only 3 pi bonds in this compound. Alright, thank you so much for having watched this video. Hope it was helpful.